Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle. And it's called Hamiltonian Killer Thermo by Koktislav. And here are the rules. I don't know why I said words. That was weird. Well, here are the words of the rules. Place the digits 1 through 9 exactly once in each row and column of the grid. So we obviously don't have the designated 9-cell region. So that's where it differs from normal Sudoku rules. We need to draw a directed path that moves orthogonally between cell centers and visits every cell of the grid exactly once. Each of the 27 cages can be entered by the path at most once. Okay, so first of all, so to move orthogonally between cell centers, it just means moving horizontally and vertically. So you can only move horizontally and vertically on the directed path. And it must visit every cell of the grid exactly once. Each of the 27 cages can be entered by the path at most once. Well, okay. It should can be entered by the path exactly once, but that's fine. Well, that's okay. That's not true because there's one cell. That's why they say at most once, because one of the cells is where one of the cells is where, or it's one of the cages is where the path starts from. So obviously, it can't enter into that cage. It's already in that cage to start with. That is, the path must visit all cells of a cage in a single continuous run before leaving it. Okay? And the path acts as a thermometer with respect to cage totals. As the path moves away from its starting cell, the sum of the cages it visits must strictly increase. So that means, say we had, I don't know, this path going something, oops, it has to be center only. Say it went something like this. Or whatever. We have something like this. That means along this path, say it started from here, this cage must be less, the cage total for this cell, this cage must be less than the cage total for this cell, which must be less than the cage total for this cell, which must be less than the cage total for this cell, etc., all along the path. So it must be increasing for the cage totals along the path. And digits may not repeat within a cage. So you cannot have something like, say, 6 here and 6 here, because they are in the same cage, and you can't have digits repeating within a cage. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so we have, this is from 1 through 9. We have 2 cell cages. We have 1, 2, 3, 4, 5, 6, 7. These are 12. So 6 here plus 5 is 11, 12, 13, 14, 15 cages. Well, two-digit numbers can only, two-digit numbers, with both of them being unique, can only add up to 3 through 17, which is all 15 cages, right? Because you have to increase continuously along the path for the cage totals, right? So, you have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That's 15 different sum totals you can have for the 2-digit cages, or 2-cell cages. Okay. So because of that, you have to have the sums 3 through 17 here, period. And this digit can only be 1 through 9, but the sums 3 through 9 are already taken by two-digit numbers. So this has to be 1 or 2. And we know one of these cages has to add up to 3. It cannot be this one, and this is the only one it can go through. So it must be then going through here. So this has to be a 1-2 pair. So that adds up to 3. Well, we need 4 somewhere along here. It cannot be here. It could be either this one or this one. We don't know. But if we tried going this one, the problem is you would have to enter in back here. And then the problem is that this path would stop and not go through all the cells in the grid. So it cannot go this way. This can't be, or it could go here, I guess. So it cannot go this way. Because if it goes this, okay, actually, this cannot be the end of a path. Right? Because it's too small. We only have 1 through 17 with either 1 or 2 missing into these cages. And these have to be bigger. So this can never be the end. Therefore, to continue, this cell must be not up. You can't have one single cell in this path. So this has to go this way and then this way to be part of the path. Because otherwise it would be a dead end, which is not allowed in any of the 2 cages. So this must be a 1-3 pair to add up to 4, because we have all the sums from 3 through 17 in the 2-digit numbers. So this is whatever, this is 3, that's 4. This is a 1-3 pair, which eliminates 1 and 3 in the rest of the row. So this is 2, which makes this 1, which makes that 2. This cannot go here because this is at minimum 4 and 5, so it has to go this way. So that means it connects here, goes through here, and this must add up to 5. So this is 3 or 4 here, and this is 1 or 2 here. That means we need... It could enter here. So this, we don't have any dead ends. We do know this has to enter in this way and exit out that way. Because it cannot enter in this way. This one must enter in and exit out that way. So then it must exit out that way. This one cannot connect to here because then that would not form a full path. So it has to enter in here. This must enter in this way and exit out that way. So this must enter in this way. If it closes here, the problem is then this would not be a full path. So this must enter in from here. Therefore, this adds up to 6. We have 3, this is 4, 5, and this is 6. So this is 7. So if it's 6, it cannot be 2, 4. It must be 1 and 5. So this is 1, 5, which forces this to be 2 and 3 to add up to 5. Therefore, this is 1 and 3 there. This must add up to 7. There's no 1, there's no 2. So this can't be 1, 6, or 2, 5. It must be 3, 4. So this is 3 and this is 4. We have to continue on to the 2-digit numbers. This adds up to 8. Cannot be 3, 5. So it's 1, 2, or 6, 7 here. So again, we have 2, 3, 4, 5, 6, 7. This must enter in here. You cannot go this way, but you could go either this way or this way. So if we go this way, okay, so remaining digits here or 4, 5, 6, 7, 8, 9. These have to be consecutive. And you cannot have 3 consecutive sums because they add up to 39 by themselves. Right? And if you have 3 consecutive sums, that would be 12, 13, and 14. Well, actually, you could do that. Never mind. That actually does work. 12, 13, and 14 does work. Huh. Okay. Remaining digits here are 4 through 9 also. Okay. 6 digits have to be at least 20. Okay, so we have 2 through 17 as sums. We need more. Okay, so this is 4, 6, 7, 8, 9. And this is 5, 6, 7, 8, 9. And this is 4 through 9. Interesting. Okay. Hmm. These digits are what? 3, 4, 6, 7, 8, 9. Okay, so if it goes this way, say it goes this way. So this would be 8, this would be 9. So let's just, yeah. Light, medium. Okay. We'll do medium, dark, green, pink, orange, red. This is yellow. So this would be 9, this would be 10. That would be 4 and 6, so that means it cannot go that way. This would then have to be 11. It could be 12, 13. What's the other way? So if it goes this way, blue, then here. It cannot go here, so it would have to go here, then it would have to double back to double here. Okay, so what are the possibilities? This is 8, 9, 10, and then obviously this can't be 11 because this is at minimum 5 and 7. Otherwise, this would be 8, 9, 10, 11, 12, 13, 14, 15, but that's too big. So it cannot go this way. If we try going this way, it has to connect to all the 2 cells first, so then it would have to go there. And there's no way that it could go this way, because if it goes that way, then these are blocked off, and they form a dead end. So it has to go this way, which means it has to go that way, which means it has to go that way. But then this is 13, 14, 15. That adds up to 42, plus 6 is 48. When we know this must add up to 45 in a row. So it cannot go this way, it has to go this way. So this is blue, so that's 10. Then that makes this, this 9, this is 10. It cannot go this way because this is at minimum 12, so then this must be 11. You have to connect to all the sums first. Sorry, 2 digits numbers first. So then this has to go this way. So then it has to go this way, which means this goes that way. So then this becomes an 8-9 pair. And this must be 7-9 to add up to 16. That means this can't be 9. This is 8, that's 9. This has to be either 6-9 or 7-8. We don't know which. So we have 2, 3, 4, 5, 6, 7, 8. This is 9. So it's either 3 and 6 or 4 and 5. Cannot be 2, 7 or 1, 8 here. This has to be 10. So this is 4 and 6. That means this cannot be 6 and 9. This is 7 and 8. That leaves this as 5 and 9 here. This can't be 9 because of the 9 in the column. So this is 5. That's 9. This is 4, 5, and 6. So we have 10, 11, 12, 13, 14, 15, 16, 17. Okay. This cannot be 9 here. Okay, so this is 10. We have 11 here. So it can only be 4, 7, 5, 6. It cannot be 6, 5. So this is 11. This is 12. No 3, 9. No 4, 8. This is 5, 7 then. Which eliminates 5 and 7 in the row. This can't be 7. This is 6 and 2, adding up to 8. So this is 12. This is 13. So this is 4, 5, 6 with 7, 8, 9. This cannot be 9 and 4. So this is, we have a 5, 6, 5, 6 pair in row 2, which eliminates 5 and 6 in the rest of the row. So that's 4 and 7, adding up to 11. That makes this 5 and 7. This can't be 7. This is 8 and 5. That forces this to be 6 and 3, which means this can't be 6. That's 4 and 6. No 6 here. No, we already have that. That's done. This is 1, 8, and 9 here. This cannot be 8 or 9 because of the 8 and 9 in the column. So this is 1, which makes this an 8, 9 pair. This has to be 4 and 6. Okay. This is 1. It could be 2, 3, 4, 8. That's possible. So it could go this way. Or, okay, so it cannot enter here because then it can't move orthogonally through all the cells in this grid. So it must go this way. So then this is 18. So it has to go here. Then can it ever form a set orthogonally here? The answer to that is no, right? If it enters here, how does it work orthogonally through each cell in that cage? It can't. So then it has to go this way. Okay, so this is 4, 6, and 8, which makes this 9. 8 eliminates 8 here, so it's 7 and 8. 7 eliminates 7 here, so it's 9 and 7. This is 19. We have 10 here, and we can't have repeats, so this is 2, 3, and 4. That can't be 4 because of 4 in the row. This can't be 4. This can't be 4. It must exit out this way because it can't enter in the middle of a cage and not exit. So then this has to go this way. This is, again, 20. This cannot be 2, 3, or 4. So we have 1, 5, 6, 7, 8, 9 there. No 6 because of the 6 in the column. 1, 5, 6, 7, 8, 9. 1, 5, 6, 7, 8, 9. This cannot be 7, 8, 9. No 7, 8, 9 there. This could be 20. Actually, both of these are 21. If it tries to go this way, that is possible. Rest of column 4 is 1, 5, 7, 8, 9. Rest of column 5 is 1, 2, 3, 8, 9. Rest of column 6 is 1, 2, 3, 4, 6. Rest of column 7, we have 2, 3, 4, 6, 7. Okay, so this can never contain 7, 8, or 9 here. Because of that, what's the largest this number can be? It could be 2 through 7, which is 45. That's 29. That is possible. So it could go something like this, and then through here. That is possible. Then through here to here. Oh, you can't do that. Because then this gets sort of blocked. Yeah, how does this work? This obviously has to go this way. This has to go this way. This has to go that way. This has to go that way. Okay. So, if you go this, you cannot enter this way. This has to enter there. So this must connect this way, which means this is a dead end here. So this has to go this way, unless, oh, I guess these could be non-dead ends. This could be a dead end, technically. Ooh, okay. This can this be a dead end? I guess it could. Okay, the problem with this, though, is this 6 doesn't work that way, right? This has to go that way. Okay. As a 6, you have to go this way. And it could be something like that, technically. So we don't know about the rest of that. This definitely has to go here. And then we don't know about this. This must go this way. This must go that way. And then it has to be one large one. Hmm. Okay. Ah, no. So, okay. If we try to make this 29, the problem is you can't have a 1 here. But where is the 1 in columns 8 to 9? They have to be in these cages. And there's only 1 per cage, so this cannot be 29 then. This cannot be the ending point, then, of the path. So this has to go here. Which means it connects to here, so that must connect this way. So that connects to this way. So here we have, this is 21. This is 22. That means this cannot have a 7. This is 1 through 6 to add up to 21. And this cannot have a 6 because it must be 1 through 7. But 7 cannot be any of these, so this must be a 7 here, which means this can't be 7. This is 1 through 5. So we know 6 has to be one of these digits here, and this is one of the 6, so this cannot be 6. So this has to have a 6 here, which means this cannot be 6 in the rest of that cage. Can this be the last one? Right. So either this is the last one because it exits that way, or this is the last one here, right? Because it exits this way. It would have to exit something like, oh, that wouldn't work. Oh, this cannot be going this way. Because this is blocked. Huh. So I think this is the dead end. Right? Oh, no, this is the dead end. So it goes here to here to here to here to here. Yeah. This has to be the dead end. It cannot go this way. It cannot go this way. It cannot go this way. Well, it could go this way. No. Okay. So one of these is the last one. So it either goes because this cannot connect to here, cannot connect to here. So it's connecting to here. This can't connect to here and must connect to here. So this would form essentially a loop within itself. So this must connect to here then. This has to connect somewhere. It must connect to here. So then this is connecting to here. That's connecting to here, which means this is connecting to there. And that's the loop. So this is, so we have 22. This is 23. 24. Which is 7, 8, 9. Oops. Ugh. 7, 8, 9. Okay. This is 25. Then we have 26, 27, and or actually it doesn't have to be. We don't know what these are. We know this is 24 though. And these could be actually any number. So there's no restriction there. We know this is 24, so this must be 23. So again, we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. This is 20. Interesting. This 7 eliminates 7 in the rest of the row. This is 21. This is 22. This is 23, and this must be 24. And there's no restrictions here, 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 or here. Except 30, obviously, is the largest you can have. Okay. 24, 25 at minimum, 26 at minimum, 27 at minimum, 28 at minimum. So we know there's a 6 here, because there has to be a 6 here for this cage. Um, this is 1 through 4, 5 here, which means there's a 4 in columns 8 and 9. There has to be a 4 in columns 8 and 9 here. So this cannot contain a 4, which means this is 1, 2, 3, 5, 6, which means this is a 4. So this is 4, which means this can't be 4 here. Where's the 4 in row 5? It must be there. That means this can't be 4. These can't be 4. This can't be 4. It's 6 with 2 or 3 here. There's no 4 here. Okay. This has to have a 5. At least. So I think this has to be... Okay, so this is... Where are the ones in row 5 and 6? They can only be in this region and in this region. So this can't be 1 here. That means this is guaranteed to have a 1. So to add up to 20, the remaining 3 digits must add up to 19. So 1... 19 could be 2, 8, 9, 3, 7, 9, or 5, 6, 8. There's no 4. Okay. So we have a 1 guaranteed here. Where are the rest of the 1s in column 4, 5, and 6? They have to be in this cage and in this cage. So this must contain a 1 also. It adds up to 23. We have a 1 and a 6 guaranteed. That's 7. 23 minus 7 is 16. Can you have it with 2, 2, and 3s? I think the answer to that is no. So 1, 2, 3, 6 adds up to 12, which 23 minus 12 would mean 1 single digit remaining adds up to 11, which is not possible. So this cannot be 2 or 3. It has to be a 1 here, which eliminates 1 in the rest of the column. This can't be 1 either. This can't be 1. This has to have a 1, and it's at least 25. Guess it could be 1, 2, 3. Okay. So we have 2 and 3. This cannot be 2 and 3 here. So 1, 6 adds up to 7. 23 minus 7 is 16. We have a guaranteed 2 and 3. So 16 with 2 is either 259 or 268, but we have a 6 here, so it would be 259. If we have 3, that means the other 2 must add up to 13. There's no 4 in either case, though, here. That's interesting. So no 4, 9. It would have to be 5, 8 in that instance, I believe. So I think this has to be 5 either way. Is that right? Yes. So 1, 6, 2, 5, 9. 2, 5, 9 add up to 16, which is what we need. Or 3, 5, 8, which adds up to 16, which is what we need, right? We have a guaranteed 8, 9 here. So this has to be 5 either way, which eliminates 5 in the rest of the column. So this cannot be 5 and 5, 6, and 8 anymore to add up to 19 with the 1. So this cannot be 6. It's 2 and 3, and it's 2, 3. So we have 1 with either 2, 8, 9 or 3, 7, 9. So we have a guaranteed 9 here. Where is 4 in column 3? Cannot be here because the 4 is in the row. Can't be here because this adds up to 24. So it must be here, which means this can't be 4 here. That means we have a guaranteed 4 in this box. That means this is at maximum 28. That makes this 27, 26, 25. So then these are consecutive. So this is 25, 26, 27, and this must be 28. So this is 4, 7, 8, 9. Oops. So 4, 7, 8, 9. Obviously, this can't be 4. This can't be 4. This can't be 4 either. No 7. So this is 28. This is 27. This is 26. And you have a 5 guaranteed here. So to add up to 26 with 5, I think it has to be 5, 6, 7, 8. Yeah, without a 1, 2, 3, or 4, it has to be 5, 6, 7, 8. So this is not 9 here. This is 5, 6, 7, 8. That's 26. We have a 5 here. And this is 27. So the rest is 22. That requires a 9. So it'd be 5 and 6, 7, 9 here. 5 obviously cannot be here. This has 4 and a 1 and a 6. And it adds up to 25. Four, 6, and 1. That's 11. 25 minus 11 means the other 3 digits add up to 14. 25 minus 11 is 14. And it has to be 2, 3, and 9. Because we don't have a 7 available. We don't have, we have a 6 already taken. And we have 4 already, and there's no 5. So no 5, no 7. So it has to be 2, 3, and 9 to add up to 14, right? So it's 1, 2, 3, 4, 6, and 9. So this cannot be 8. Okay, this can't be 7. Where is the 8 in row 7? It has to be here. So this is 8, which eliminates 8 in the rest of the cage and the column. One of these two is a 6. Where is the 8 in column 2? This can't be 8 here, so this must be 8 here. Which eliminates 8 here. So this is a 5, 7 pair, which eliminates 5 and 7 in the rest of the column. So this can't be 7. This is 8 and 9, which forces this to be 7. This 5, 7 pair eliminates 7 here, so it's 6, which means this can't be 6. This has to be 5, 6 with 7 or 9 here. This is 7. We have an 8, 9, 8, 9 pair in row 9, which eliminates 8 and 9 in the rest of the row. So this can't be 9. This is 7. This can't be 7 or 9. It's 4, which makes this 9, which makes that 7. No 7 here. This can't be 9. This can't be 4 or 5. So this is a 2, 3 pair, which eliminates 2 and 3 in the rest of the row. This can't be 2 or 3. It's 6. That eliminates 6 here. These can't be 2 or 3 because of 2, 3 pair in the cage. This is guaranteed 6. We have a guaranteed 2 or 3 here. This 9 eliminates 9 here, so this is 8, which makes this 9. This can't be 9 either. This 9 eliminates 9 here, so this is 8. Okay, so this adds up to... So 13 plus 7 is 20. And then it must add up to 23, so this is 3. So 3 is no longer here, which means 2 has to be one of these 2 digits here. So this cannot be 2 here. Where is the 2 then in row 8? It cannot be here because of the 2, 3 pair in the cage. It can't be here because of the 2, 3 pair in the cage. This can't be 2 because of 2 there. So 2 has to be here, which means this cannot be 2. Whereas a 2 in row 6, then, it has to be here. So this is 2, 8, and 9. Oh, we sort of already knew that. Okay. This can't be 8 because of the 8 in the row. This 6 eliminates 6 here, so it's a 1, 5 pair, which eliminates 1, 5 in the rest of the cage and the row. This can't be 1, so it's 9. This can't be 5, so it's 7, which makes this 5. This can't be 5. These can't be 9 anymore. We have a 3, 6 pair, which eliminates 6 here, so this is 9. This cannot be 9 here. This 8 eliminates 8 here, so it's 1, which makes that 8. So this cannot be 1 here. This is 2, which makes this 6 and 3. This 2 eliminates 2 here, so it's 3 and 2. This 1 and 3 eliminates 1 and 3 here, so it's 9, which makes that 1. 1 eliminates 1 here, so it's 5, which makes this 6, which makes that 5. So this 5 eliminates 5 here, so it's 1 and 5. 1 and 5 eliminate 1 and 5 here, so this is 4, which makes this 1. 2 eliminates 2 here. 3 and 2. 3 eliminates 3 here. That's 3 in the corner. We celebrate because we know we're solving it. This 4 eliminates 4 here. 6 and 4. And that's the solution. Yeah, interesting sort of rule set, actually, I guess I would say. Particularly with the shapes, right? You have certain restrictions that you have on these shapes. So fairly straightforward in solving it. You just have to know, like, the restrictions that you have for the cages, right? Yeah, fun little puzzle. I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.